Hello, welcome to this next video in object-oriented programming Python with coding-bootcamps.com. The rest of the videos in the course are going to be projects, all covering class concepts. We may get to a few other class concepts, but only as they come up in projects. So the first project, we're going to create a car class with 3 subclasses, and the subclasses will be sedan, convertible, and minivan. And we want to make a number of attributes or variables or member variables that go with each of those classes, some methods, and we want to practice some things such as overriding functions, adding functionality, things like that. So I'll just put everything I want in the program at the top. So for project 1, create a car class with 3 subclasses. Subclasses sedan, convertible, minivan, that each inherit the car class. Create a static variable inside of the car class that says something about all cars. So a static variable, if you remember the example we had before, the dog, would be like this line that says species Canis familiaris. That's a variable that you define a value for in the class that isn't related to a specific instance, but it's related to the class as a whole. And it helps describe something about that class object. So all dogs have the species name Canis familiaris. So you can define the name of the species in the class because it's not going to change from object to object. And basically static variables, they're defined they're not exactly defined once, they're kind of defined in general for an entire class. So I wanted to create at least one static variable for all cars, so just create a static variable that defines cars that you wouldn't want to be related to just one instance of a car. Static variables are not defined when an object is created because they are not in the class constructor. Instead, they're in the main class. They're just in the class. And describe the class in general. Create at least 4 variables that describe the car, such as name, model, mileage, things like that. Come up with your own. Create at least 3 member functions. Member functions are methods that use the car's class member variables. I want at least one of the methods to be overwritten in your subclasses, and at least one of the methods should take a parameter that isn't defined in the class constructor. So at least one method should take in parameters that are not in the class constructor, and at least one method should be overridden. Actually, I'll put it below. override a method at least once in each subclass, and expand on the function definition in each subclass. Also include at least one new method in each subclass. And then finally write some code to test your classes and create at least 4 objects. 4 objects or instances, one for each subclass and one for the parent class that, to test all of your class code. Okay, so this is the first project. It's a basic introduction. Some of the later projects are going to be bigger. Especially, we should have about 3 or 4 projects, and the last one will probably be the biggest. I think for the last one, I'm going to finish the blackjack game I made below. That's going to be a much larger program. Or we might only, we're going to do anywhere from 2 to 4 projects, depending on how long they take. So if you want to not see my solution, I would pause the video here. And right about now, I'm going to start creating my own class for this project. Okay. So for my car class, I'm going to start with class car. We want 3 subclasses. Click pass for now. We want 3 subclasses. And I'm going to name them sedan, convertible, and minivan. And then I want to create a static variable inside the car class that describes all cars. I was thinking maybe just calling them vehicles. Or I'll just say the size of the vehicle, or vehicle size. You can come up with anything you want. It's not particularly important if it's useful. I just wanted to show a point by making a static variable. And we can test that later. So vehicle size, small. So I wanted 4 variables that describe a car, so I'll just use the ones I made above. So we need our initializer, constructor, name, model, mileage, and just put color. Self.name equals name, self.model equals model, self.mileage equals mileage, and self.color equals color. Those are our 4 variables, and then we want 3 member functions that use the car class as member variables. So I guess I'll come up with a print function. Model. Print. Name and model are kind of the same thing, so I'll get rid of name. Instead, I'll put like license plate number. Self dot license plate number. By the way, if you're using an IDE, most of them, when you're in the process of typing a variable you've already defined, like license plate number, a window will pop up as you're typing it, and then if you press enter, it'll automatically fill it in. So just a quick shortcut. I haven't figured out how to clean it off yet in Python, but I'm not concerned with it. So define print model. Model is a car. Two more. But I'll do miles to kilometers. Do model this self model as mileage string. Another thing is, just really quickly, if you're defining variables, because Python automatically types variables and you can't explicitly do it, meaning if you assign a value to a variable like a number, it's automatically going to make that an integer or a float. When you're coming up with messages, you have to type it as a string and not throw an error. Something really quickly. So if I didn't have the string in here and I assigned a number to the mileage value, then without this string, I'd get an error for this function. Because you cannot add numbers in Python to strings, because it won't know what to do with the addition operator, whether to concatenate it or add it to the message or try and like do mathematical addition. So this model has miles on it and which is string mileage times 1.6 kilometers. And then the license plate number. So I just did a bunch of print statements. In the next project, we can do less printing of messages, and we can do a lot more trying to come up with more meaningful functions that like work with numbers and things, but for now, just do print statements. Print the license number of this model is okay, so we have our three methods, we have our four member variables, and let's say we wanted, okay, so we want one parameter that is not in the class constructor. I'll put it in model. Actually, I'll just, instead of this function, we'll just make a I'll make a fourth function. I'll make an add mileage function, and it'll take in a parameter additional mileage. So add mileage self add mileage function. So mileage, then do self dot mileage plus equals more mileage. Okay, so now if I use the add mileage function, I can add on some mileage with the car. Okay. And then override a method at least once in each subclass, and then also include at least one new method in each subclass. So for sedan, should probably override the model function, so we'll do this. Convertible. And it is sedan. And then if we made just a general car that wasn't one of these three types, then like a pickup truck or something like that, then we can just print out a general message that just says to make the car. Okay, and then to override it, add anything. So you don't need to use the super function to override a function in the parent class. It's just if you want to reuse code, but we're printing out an entirely new message. So we could do it like this instead. Do print super dot print model. Or I guess super dot print model plus star is a sedan. So now we'll print two messages instead. Convertible. And then I want one new function for each of these cars. Sedan. I'm gonna look up some car models real quick. It's hard to think of functions that would be useful for one type of car versus another in terms of like sedan versus convertible. For convertible, you can just put or this car. Car holds 7 people. Not 7 people. Change the names of the functions. Okay, so we overrode, we have 3 new functions. We overrode the print model function. to include additional information about what type of car it is, and then we also have the base class, which has 4 numbers in it. So now we need to test all of this to make sure that all of our code works. So to run it, I'm just going to print model on 4 cars. Let's say car equals car. So it's model, mileage, color, and license plate number. So 2021 Ford F-150, and that'll be our general car. Put mileage on it, 30,000. Let's put color and license plate, silver, and then make up a license plate number. AEY, numbers, I'll copy and paste this. New sedan, new convertible, and new, actually I'll name them after the models. So do Ford F-150, sedan, Toyota Corolla. I'm not good with cars, so I don't really know car models. Toyota Corolla. $50,000. All these. Blue, black, and white. Numbers. Okay, and then to the Corolla. Ford Mustang. And then our last type was a minivan. Honda Odyssey. Okay. Ford Mustang, and then Honda Odyssey. Okay. So we have our 4 objects, and now we need to test our member functions. So the first thing I'm going to do is I'm going to use the print model function on all of them. model, 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 model. Okay, so we printed out the makes of the cars. Okay, oh, that's what I'm missing. I'm missing. Not too hard. One. Card up vehicle size. Not card up, but vehicle size. Ford 50. Vehicle size. Okay, I just put small for all the cars, even though it's a truck, but as opposed to like an actual truck, like a 10-wheel truck or something. So we have the 4 print models. We got to change it so it overrides. We don't need to use the super function, but I'll just recomment the statement. Okay, so we have prints. Okay, that doesn't make sense. Okay, so it's not inherit. It's not using the overridden function. Just put it back. Just do super print model. Super print model. I'll leave this one so we can test, and then just change. line 90. Oh, I figured out what I was doing. Make them all car objects. This is sedan. This is convertible. And then this is minivan. Okay, so as you can see, the Ford F-150, you only have the make of the car being printed, but for the Toyota Corolla, the Ford Mustang, and the Odyssey, we also print an additional message saying they're a sedan, a convertible, or a minivan. Also, to reuse the code, we use in the parent class, we use the super function, so it's super.printModel. So super.printModel will go back to the parent class. It'll fetch the printModel function from this class and reuse that function in our new function. And we created 3 new functions, so we've got to use those. So use 3. Sedan, convertible, and minivan, run, put some line breaks. Okay, so we printed out our static variable, which says the Ford F-150 is small. We printed out the make of the Ford F-150, and it's just a car object, since we didn't make a truck class. So it just says the make of the car is Ford F-150, and it doesn't say anything about it being a truck, so we just defined it as a car. Then we created a sedan, a convertible, and a minivan. And for each of those, an additional message is printed out saying what type of car they are. And then we printed out some information about what a sedan is like, what a convertible is like, what a minivan is like. And all of our code is working, which means our classes work. Inheritance is working because we overrode a function. And they're able to use the same variables. So I'll print out one more thing. I'll print out the license number of all 4 cars. This. That was the only thing we need to change. So, Mustang, and then Honda Odyssey. And we're going to do license number. Actually, I'll do something that we don't have a print statement for. Just do mileage. So this will print just the mileage in miles, not in also kilometers. And then there are mileages printed at the bottom. So we were able to access the variables that we defined in the parent class from the subclasses. So yeah, that's project number 1. It's a very basic program. I'll probably do one more project that'll be a little bit bigger, and we're going to build a sample blackjack game. and in that we'll actually be using card object, a deck object, and create a main function which plays some of blackjack. We won't create a full blackjack program. We'll just have some basic gameplay in it. Because it would take way too long. It would take several hours. But yeah, this is project number 1. I hope you came up with something similar. If you want to get extra practice, you can add extra functionality to the different classes. You can try adding new classes. You can try adding a class that inherits one of the subclasses, so something that inherits minivan. Just whatever you can do to mess around with it and get more practice in Python. So yeah, next video will be project 2, and thanks for watching. Bye.